In this video, we will be going through the steps necessary to set up the intersector as though you were at a live intersection. We will be using a simulation mode that we have built into the product where you can simulate vehicles moving through the grid. With this, we will go in and set simulation mode 2. Simulation mode 2 will show 2 vehicles traveling through the grid. We will also change the delay before max from 80 to 90 seconds. This is a parameter that is given to us from the traffic engineer typically at the intersection. We will also change the RF channel from 1 to 4 just to demonstrate how to change the RF channel. After this, we will go into our zone setting tables, and there's a lot of stuff here, Brian. What else is going on here?
We have 8 different zones on the table. We have a Y feet and an X feet, which are going to be where you're placing your zones. We have a Y front and a Y behind, which is going to show where your zone is starting at and where it's in front of the zone or behind the zone. We have a width of the zone, which is normally 12 foot for each lane, 24 for 2 lanes. We have a delay time, which is going to give you a delay before that zone is actually activated once the vehicle is in that zone. We also have an extension time, which will hold the call after the vehicle has left the zone. We have 8 different Opto outputs, 4 per each card. And then we have a vehicle count, we have bike, pulse, and zone descriptions. On the bottom of this table, there's going to be a vehicle table, which is going to give you each vehicle an ID. It's going to give the vehicle number. It's going to give the Y position, the X position, and the speed and the classification.
So that describes kind of an overview of the screen. To the right is the grid where the vehicles will be tracked as we're watching vehicles travel through the intersection. So next up, we will set the sensor orientation. When you install the intersector, it's looking typically diagonally across the intersection, and by doing that, you'll see the cars moving diagonally across the grid. We can change the angle from initial value of 0 to -9, which is a value we determined earlier in the worksheet that Brian did. We will change it to -9 degrees, and once we've done that, then the cars will be coming straight up and down through the screen. And the objective is to get them moving parallel to the lines near your stop bar zones. Next up, we will stop the vehicles with the stop button. We select from the vehicle table which car we want to copy to the zones. We notice we have ID number 1, vehicle number 1, and we copy that to zone number 1. Temporarily there, you will have seen the zone flash yellow. That means any changes have not been saved yet. We've copied the zone to where it needs to be, and we've set zone data to make it real. With that, we've then set the zone exactly where we want it, centered on the vehicles moving through the screen. Next up, we'll set some speed bins. With the speed bin, for first time, we will set it to greater than 35 miles per hour, and we will see that we don't get an activation because the cars are actually moving around 31 miles per hour. So that's a good way to set a fast zone. If we want to set a zone that is slower in speed, we set one greater than 0 and less than 35. And in this situation, we will see now it is able to detect these vehicles. These vehicles are traveling around 31 miles per hour, so they're less than 35 and they're greater than 0 miles per hour. We also have pulse mode. With pulse mode, when we click it, you will see the zone box turn blue when there's an activation. When it turns blue, there's a 125 millisecond pulse that comes out of the TCIB card into the controller. We also have bike mode, and if we set bike mode in this case, you won't see a detection because these vehicles are not being classified as a bike. They're only classified as a car. They're both classified as 14.4, and you can see that's a typical car. Breadcrumbs is a great feature we have where you can see statistically where all the vehicles are traveling as they approach. In breadcrumbs, it leaves a dot on the screen for every time it samples where the car is at. Cars vary quite a bit in the lane, so if you get a statistical view of that, it helps us in setting the zones so you can ensure that you capture all the vehicles as they come up to the stop bar. After breadcrumbs, we have another mode called tech mode. In tech mode, sometimes things are just too cluttered on the screen and you want to simplify things. So if you take tech mode off, every vehicle that enters the zone is not shown, but the zone activates just like normal. So it makes it a cleaner look on the screen. Next up, we have a feature where we can extend a tail behind the radar dot. The dot we show is the front edge of the vehicle. When we put extend on, it extends a line 18 feet behind that dot. We show that show up on the screen as a little blue line behind the dot. So this is very useful if you have a crosswalk and you want the vehicles to still be held even though they might pull out into the crosswalk. We can also add a zone description. This is just a text field where you can enter in some feature about the zone being a right turn, main, left turn, through lane, whatever you want to add. Next up, we demonstrate changing a zone length. So we change the zone length from 20 feet to 100 feet. That shows how easy it is to change the dimensions of a zone. And it's all in feet and it's all just math. So anytime you want to add numbers, you can make a zone any size you want to. We can also, if we need to change the Opto Output, we can change, say, output 1 to be output 4. Again, set zone data. And now we can see on the Opto Output screen, output 4 is being lit up. Sometimes the display is not exactly centered in the grid where you would like for it to be. So in this case, I moved it to 175 and it still wasn't quite centered. We moved it to 200 and now it's centered quite well inside the grid. Next up, we'll set a wrong way zone. So the zones can be set, normally the zones are set for approach. In this case, now we've set the zone for wrong way. So these are useful in certain applications of exit ramps or entrance ramps from interstates, or if you're just wanting to track cars departing at an intersection. In wrong way detection with these cars approaching, the zone will not activate. In our simulation mode 16, we're able to have cars in bidirectional modes, both approaching and departing. And now we see vehicles approaching and departing. And again, the approaching vehicles do not activate the zone. So if we move it over to the departing cars, now we see it's orange as it's continuously detecting. So we'll shorten up our zone again and we'll take away the extension timer, which you can see the zone turning on and off as cars go over it. So with these settings, we're able to go out to the intersection and set up the zones and analyze what's going on to make sure that we get the zone set properly. There are many other parameters that we set out there in order for a proper setup, correct, Brian?
That's correct, and we'll show that in the next video.
Very good. The next video will be live, and we look forward to seeing you then.